Hi, I'm Mike Hoyer, HBK Applications Engineer, and this is a short video on setting up an IEPE sensor for an electric drive test on a Genesis Power Analyzer. The Genesis Dynamic Power Analyzer offers a wide variety of input cards for recording numerous types of signals, including sensors. Now, here you can see a list of cards that offer IEPE signal conditioning. In fact, in this example, we'll be using a GN840B universal card. It's the one that's listed at the top to condition an IEPE accelerometer. HBK offers a wide variety of sensors for every application. For example, in 2019, sister companies B&K and HBM merged to form HBK. And as you can see here in the list, both offer an extensive array of sensors. In 2022, HBK acquired Dytran with a full line of piezoelectric and DC MEMS sensors, and in 2023, HBK acquired MicroStrain, specializing in microdisplacement, inertial, and wireless sensors. Now, in this example, we're going to be using a Dytran 3056D2 IEPE single-axle accelerometer. Now let's talk a bit about cabling, starting with the Genesis GN840B 8-channel universal card. It has ODU connector inputs. Now this will require a Genesis cab 2124 ODU to ODU cable, which is connected between the card and the Genesis G090 DIN rail BNC breakout block. Then we use a Dytran 6011A cable to connect from the BNC breakout block to the output of the Dytran 3056D2 accelerometer's 1032 connector at the top of the sensor. Now, the first step in setting up the Genesis perception software is to make sure that the sensor to be used is in the sensor database. Now, in this example, we'll need to add the sensor to the database, and we first need to click on the Sensor Database tab or sheet. Step 2, we click on the IEPE sensor icon as seen in the red box, which will add an IEPE sensor to the User Sensor Database IEPE list. Next, on step 3, we enter the parameters of the sensor. Now, in this example, we've added all the parameters for the Dytran accelerometer, and then click Apply to save the parameters to the sensor database. Next, we'll need to configure the amplifier or input channel for the accelerometer. Now, I have the GN840B universal card in slot B of the mainframe, and the accelerometer is connected to an unused input channel, in this case, channel 2. So first, we'll click on the Settings tab sheet, then click on Analog Channel and select the amplifier mode on channel B2. We'll set it to IEPE. Next, we'll click on IEPE in the input list and select the sensor that we previously added to the database. That's the Dytran 3056D2. Once selected, we'll see all the parameters for the sensor automatically entered into the channel for span, technical unit, and the technical unit multiplier. Here we've created a custom display using the Data Sources Navigator on the left. We can click and drag each signal that we wish to display. So in this example, from top to bottom, we've selected the IEPE accelerometer, and then the phase 1, 2, and 3 raw current and voltage signals, each within their own pane for each phase. And at the bottom, we've added the torque, speed, and position. So here we can observe any changes that occur in vibration from the accelerometer and correlate them to the voltages and currents, as well as torque, speed, etc. And we're done. That's how quick and easy it is to add an IEPE accelerometer sensor to your electric drive measurement. Now, more details are available on our website at www.hbkworld.com. And for technical support, you can use the emails listed here. For North America, support@usa.hbm.com, and worldwide, support@hbkworld.com. and we're looking forward to hearing from you.